Hello students, let's continue. And still the same graph, but we want to do a different type of search. Now we want to do the DFS, the depth first search. Okay, so for the DFS, and we are asking for for each node, we want to show the start and finish time for each node, and then the pi array. And again, the pi is for the parent, and in addition, we also want to have the edges for the type of the each edge, okay, the edge type. And since we are doing an undirected graph, we will only have tree edges and back edges in this case. Okay, so well, let's start. We are also going to start from 0. Okay, so we are going to start from the 0, and for each of the node, I'm going to use two values to show you when is the start date and when start time and the end time. But in the algorithm, we are using the D and F. D is for the discovery time and F is for the finishing time. But anyhow, well, let's do the easy way of using our pen first, and then I'm going to fill in all those values. Okay, so for the 0, we are going to start from the time 1. Time 1. And then from the 0, and then we will say, okay, you are gray for now. We haven't really finished that, but let's go to your first neighbor. And who's your first neighbor? And for 0, if we are considering all the adjacent nodes are sorted from low to high, and then we will go to 1. So for the 1, we will have the discovery time as a 2. And then what do? We are going to go to 7, right? So, and then we will go to 7, and 7 will be 3. So at this point, the 1 will be gray, and 7 will be gray. So after we visit 7, we go down and we visit 2. So at that time, and let me do the start time for 2, which is 4, and then for the 2 it will be a gray. And then for the 2, there are two neighbors, 3 and 5. Where should we go? The answer is 3, because 3 is a lower number. Remember, we always go visit the nodes using which that has the lower index. So we will go to the 5, and then 3 is also gray. Okay, so we have gone really so far, and let's fill in the parents first. So for the 0, the parent will be a nil, that's for sure. And for the 2 has a parent to be a 0. Sorry, for the 1 has a parent to be a 0. And then for the 7 has a parent to be a 1. And then for the 2 has a parent of 7. Okay, and then for the 3 has the parent as a 2, so 2 here. Okay, so I have filled in all the parents for the nodes we have already touched. And where else do we go? From 3, we can go to 4, so discovery time will be the 6. And then for the 4, let me paint it gray. And then what's next? The next will be 7. When we visit the node 8. Okay, 8 is also gray. Okay, I do want to pause here for now. And well, I remember at least one student asked me this question. Well, the question is, it seems that for the DFS and the BFS, they are kind of similar. What's the difference? Okay, if I pause here, I should be able to answer your question. The answer is, well, if you see this one, and we have definitely discovered a lot of the nodes. And what's the problem? The problem is they are all in the gray color. In the gray color, what do they mean? This means we have started visiting those nodes. However, they are gray, saying we haven't really finished discovering or touching all of the adjacent nodes for 2, for example, right? So we just decide there is one way for we to go deeper, so we go deeper. So as a result, from 0 to 1 to 7 to 2 to 3 to 4 to 8, we end up with a trace of the green nodes. For each of the green nodes, we don't finish them, and then we don't know if we have if we have touched all the neighboring nodes. We don't know that. And starting from this point, and we will find that for the 8, there's nowhere to go. There's no adjacent white nodes, so I'm gonna black this 8 and say, okay, the finishing time is 8. And then I go back, I go to 4. And for the 4, there's no other nodes to go. So for the 4, the finishing time will be 9. And now you are also black. And then for the 3 finishing time will be a 10. You are black now. And then for the 3, there's no other nodes to go. So we go back, and how about 2? Okay, for the 2, we do have another neighbor. So another neighbor is 5. So 5 is also great. And then the discovery time of the 5 will be 11. And then for the 5, we go to the 6. So 6 is also great. And then the discovery time will be a 12. And then we find that from 6, we are going to nowhere. There's no more white nodes, so that's black. So we have 13. And then for the 5, there's nowhere to go. So for the 5, we also finish that. We painted black, and then we have 14. So 2 is also black with 15. And then 7 black, 16. 1 black, 17, and eventually 0 is black with 18. Okay, so for the 5, the parent should be a 2, and then for the 6, the parent should be a 5. Okay, so well, for those numbers separated by a column bar, they are the discovery time and the finish time. So for the 0, it should be 1 and 18. For the 1, it is 2 and 17. For the 7, that is 3 and 16. For the 2, that is 4 and 15. For the 3, that is 5 and 10. For the 4, that is 6 and 9. And for the 5, 11 and 14. And for the 6, 12 and 13. Okay, so this is how you fill the D and F. And by the way, those are terms we use in our algorithm. And from time to time, just to make the illustration easier for the student to follow, I will use the colors. However, you do have to understand that if we are tracing the algorithm 100% based on the version we use. Okay, I think I missed this one. Okay, based on the version we use in our textbook, and then we are using the D for the discovery time, F for the finish time, and pi for the parent. Okay, the next step, how about I highlight all the edges and see for all the edges between a node and the parent. So for 0, and then for the 1, 1 goes to 0, which is here. And then for the 2, 2 goes to 7, which is this one. And then for the 3, 3 goes to 2, which is this one. And then for the 4, 4 goes to 3, which is this one. And for 5, 5 goes to 2, which is this one. And for 6, 6 goes to 5, this one. And then for 7, 7 goes to 1, okay, here. And then for the 8, 8 goes to 4, like this. Okay, so for all the red edges, what are they? They are the tree edges. Okay, and then there is a theorem in our textbook and also in our lecture notes that is for an undirected graph. After we have done the DFS, there are only 2 types of the nodes, 2 types of the edges, the tree edges and the back edges. Okay, so for this edge, this is a back edge, and for this edge, this is another back edge. Okay, so this is my solution to this problem. So let me show you the problem again. So just now we say, well, for each of the node we want to label the start and the finish time, and then we have the pi array, which is an array showing for each node, which is a parent, and then for each edge type, and we have already labeled all of them. There are only 2 edges as the back edges, and for the remaining of them, they are all 3 edges. So this is my example about the DFS. Okay, so well, I feel there are really a lot to review, but I want to stop here. I will post all the four videos I made today, and plus the lecture notes for today's review session. Okay, so I will see you later. Bye.